so I can go on line for a few minutes with this praising him, but I will not waste time and continue with Dr. Peter Zeno to continue with the session.
Well, hi, it's great to be here. I really appreciate it. We're having some really strange weather here in Pittsburgh right now. It's super foggy, really weird. It's a little after 8 in the morning. But yeah, it's great here. So let me go ahead and share my slides, and that way you can all see what I've been working on. So would be that one. Oops. Okay, so can you see my slides up there?
Yes, it's visible.
So the interesting thing is it's not going to slideshow. Oh, there we go. All right. So everybody sees that okay?
Yes, sir.
Great. All right, so my talk is on do-it-yourself autonomous robot projects. And that's what I've been doing for the past 2 years, I would say. So my educational background, I have a few degrees, mostly electrical engineering, computer engineering. So I have approximately 30 years in industry working for a lot of Department of Defense contractors like Raytheon, Lockheed Martin, MIT Lincoln Labs, and Synopsys was different. I did some software design and verification for ASICs. I've taught microcontroller, microprocessor labs, and FPGA design labs at 2 universities. So I established my company in very late 2019. So I started doing a lot of teaching of actually using the Arduino board as sort of the base to teach people the, sort of the beginning concepts of doing C programming, plus getting data from sensors and interfacing with sensors. So as you're saying, I offer prototype development, and which I'm doing right now for someone who has a startup and they have an invention that they want to do. And also I'm putting together some classes on drones and ground vehicles, autonomous ground vehicles. So the beginning origins of my interest in autonomous mobile robots was when I did my PhD. So I was creating a SLAM, which is a simultaneous localization and mapping algorithm based on the specialized spatial awareness cells of a rodent, but they're similar in humans and insects and many animals. And so I created this robot to be able to kind of put together a map using some very basic sensors, but sort of using what they call place cells and head direction cells, but that still very well maps into the way robots work. So that's used for like pose, figure out your pose, and but the incredible thing is they don't have all that detail as we do today with LiDAR, but they're able to figure things out as we can for where to go and where we've been and dealing with dynamic situations. And also, so it was mid 2020, at the beginning of the pandemic, that I learned about the DARPA Sub-T challenge, and I wanted to see if I could put a robot together. But unfortunately, it was canceled later that year. At least the systems, they did the virtual, but but that's where I started to learn, ROS. And so the interesting about this challenge was the underground environment. So it was GPS denied. And so most of the mapping was done with LiDAR, not too much visual, although visual was used to help identify what they call artifacts, which would be like a dummy that looks like a person that has a thermal image and fire extinguisher, cell phone, which gave off Bluetooth and Wi-Fi data and things like that. So I did work with the guys at Carnegie Mellon University for a while, the Team Explorer, with their robots, but they pretty much already had them developed from a couple of years back. They had placed pretty high. But the diverse environments was interesting because typically when you make a robot, you make it so it works with a single environment. You want it to be able to do its best in a single environment, say farming or something like that. But yeah, so you can go from caves to an urban environment, which is very much more structured, to tunnels. So that was pretty interesting. And this is one of their robots, CMU's robots, and its air vehicle. I guess that was a student designed UAV. You can see the LiDAR on top. It's a 3D LiDAR, very expensive. That's a spot. So I started with this Tankbot. So I bought the chassis, and I have a couple batteries at the bottom. I put together a light, LED light, and so I had a webcam on there and 2D LiDAR and Raspberry Pi. Also, I have a Mega board, so it's Arduino Mega. So I was actually doing ROS serial. It was communicating between the Raspberry Pi and putting up a ROS node in serial, and the Raspberry Pi was doing the rest. But I had this initial interaction with the Arduino because I already had, from my Rapbot, I had all of this IMU interface, and I could also control the relays for the lights, and I can also get odometry information. So I already had all that code, and to take the time to convert it over would be rather time consuming. So that's why I went with the ROS serial. And then the my latest is this drone, this quadcopter. So this actually has a Raspberry Pi for the companion computer. So it can do autonomous flying. I actually have a camera coming, hopefully this week. They said the 14th, but it's already been sent from Florida. So that is the, well, I have more detail on that. I'll get into that later. So this is just the mapping, showing you the 2D mapping of the Tankbot in action when I was living in Idaho. So I was actually doing the control here of the Tankbot. I also then changed the code so that I could grab data when it was at certain angles, the LiDAR was at certain angles, so that it would check to see if it was going to collide into something. So it was actually autonomous. It would actually steer its way around. But here you can see it's generating a 2D map, and that's the vector of its pose. And so that was actually not too bad for the cost. 2D LiDAR is, I mean, you can get one for about $100. So the next thing I'd like to do is actually to put a better SLAM algorithm, because this one is just collecting data, but it's not able to actually use that data the way it is, because it's, I think so that's the Hector slam. It's not actually using pose information. So you need the combination to be able, well, depending on the slam algorithm, but most of them use the pose information besides the mapping. So I'll stop that there. Okay, so yeah, on the Tankbot, it's what you call an autonomous mobile robot, or an unmanned ground vehicle. I had the Mega Raspberry Pi 4B, 2D LiDAR, the IMU, the camera. As you can see in the video, I had the camera going also. So I had all of that being sent over via Wi-Fi connection, so I could see it on my remote station. And so then I had the Ubuntu and ROS using C++, ROS serial, Python, which was being used on the Raspberry Pi and the Hector Slam. So actually, from doing this project, I had never used ROS before. I never. So it was interesting. I got a book and like broke it out, and there's a lot of stuff online, which was very helpful. I learned the 2D LiDAR format, so I was able to figure out what data stood for what angle, and ROS serial, and then the Hector Slam. So the next thing I want to do is to add a camera. Actually, I do have a RealSense D415. The only thing is I'm having a bit of a problem with, I think it might just be the processing power. And from what I understand, a lot of people, someone has done like a handheld 3D LiDAR, and I've done this on Raspberry Pi, but it like freezes up pretty quick. So I may need to get something like an Intel Nook, which would be big money, at least for me, for just this. So I'm not sure yet on what I'll do. So the Quadcopter. So this was definitely the largest learning curve project thus far, because I had never worked with a quadcopter other than the Holy Stone that I bought, and it's like, it has a camera, and it's just one of those, you pull it out and start working with it, and it's fun. It's a fun thing. But there's no modes. It's just pretty much just one mode. So then I went up to the Ubuntu 20.04 on the Raspberry Pi. I got an 8 gig main memory on that. And it actually, it was kind of hard at first. I mean, a lot of things are easy at different versions of Ubuntu. And it's like some things break the next thing. And it's like, oh, suddenly you can't use the Wi-Fi from one version to another. I mean, even last night I was playing with the Jetson TX1, and it had Ubuntu 14.01. And so I upgraded it a bit, and unfortunately I broke it because it no longer boots. So you have to, and I guess it was made before some of the later versions, 18.04 or so. So that's kind of a thing you have to think about. But I have that lined up in here to talk about. So this is the main system of the quadcopter. So learning about the Pixhawk. So that's your flight controller unit. So there's various modes you can put it in. And so you learn about the telemetry, programming it, which you don't have to do. I mean, you can use a ground controller, Q ground control, or a mission planner if you want to do ArduPilot. But I was using PX4. So I was using Q ground control. And you can actually, what I did was set waypoints. I think I have it here. Oh, this is it flying. So I had put that into a mission mode. So I thought I had a slide here on that. But anyway, so the required parts for the drone was the Raspberry Pi 4. I actually put an 8 gigabyte and the ESCs so that they are able to talk to the motors and get the right voltage out, RC controller, props. So another thing was learning what props, which one of the motors go counterclockwise. They have to balance them out so it doesn't spin and it stays up. And also, how the blades are facing. They're different on, obviously the way they're spinning. So, all that I was trying to take off, but I was actually trying to drill it into the ground. So that wasn't a good thing. Yeah, so learning about all that and the connection. So I have it out here in the field. And so the biggest problem I've had is with the GPS not working. And I'm starting to wonder about the communication interface with the Pixhawk. If that's, the one telemetry interface works fine, but I had a problem with connecting the Raspberry Pi to one of the telemetry ports. It wasn't talking until I put it into the USB. And so I have a connector coming today that I'm going to just test out and try to feed through the receiver, the GPS receiver, into the USB, see if that works. If it does, then I probably crashed this Pixhawk too many times and something internally must have, it doesn't seem like it would, but something was an issue. So the PX4 consists mainly of 2 levels. I learned this about it. So it has a flight stack, which does the estimating, it has the sensors feeding in, and it's able to do the controlling of balance if you have it in that mode. You can put it in acro mode and you're totally in charge of getting that thing going. And then you have middleware, which is that sort of an autonomous layer. Oh yeah, so this is the one I was talking about. So in the ground control, ground control, I would, you just put waypoints where it takes off, and you could put, and then where it lands, and then the various waypoints set the altitude. And as long as you have, like this thing showing like 10 satellites, you can set what the minimum is. I could set it for 4, but still I have a hard time getting even 4. Sometimes I get 7, it still doesn't even lock with the GPS. So I don't, sometimes more. So I don't know. And also then you're able to do the different mapping of your transmitter. It'll show you what, where the sticks are at, and you can program that in. And then also do your sensor setup to set, and you want to do this on a very level plane. So you're able to, and the Holy Stone's like that too, but you could do it out in the field, and it doesn't really care too much if you mess up a little bit on the angle. But so you set your sensors to be able to program the compass and the gyroscopes and accelerometers, and all that's on the flight controller unit, which is the Pixhawk. So this is showing the simulation connectivity. So I can run this purely on my workstation, and that's where I do like the programming initially to see if I can get into offboard mode, or just anything you want, any mode that you want. You get the GPS, simulated GPS through what was it, Gazebo. Gazebo would send that information, also the physics information, And so you can do a simulation on that. So lessons learned from doing this project, which was a lot, was to learn about drones and their supporting software, like the Cube ground control station and ROS Mavlink. You can also go with ArduPilot. There seems to be a lot more information on ArduPilot and Mission Planner than there is on the PX4. I mean, there is information on Pixhawk and the Q ground station, but it's not quite as clear as it is. There's a lot more videos and stuff you can get with the other two. So yeah, so as soon as I get a GPS signal, or I put this RealSense in, which will be next. This is actually very hard to get a hold of right now. A lot of places don't have it coming in until after December. I paid a little extra money to be able to have one coming this coming week, but it has built-in visual SLAM, and it gives you your inertial odometry, visual inertial odometry. So when it knows when it's moving, it can, as long as it's kind of picking up something visually and the movement of that visual, it'll give you odometry and information. So it's very interesting. It's also very ROS friendly already. So it'll be interesting to see how that works and how that develops. So kind of the gotchas of it, of the do-it-yourself, is you have to, especially when it comes to anything that's a little bit complicated and you need an operating system, like a Linux operating system, you have to see what plays together and what doesn't play together. Because like you suddenly break things from one version to another, like I was saying before, and you can really go down a rabbit's hole at times, Googling and trying to find out. It's like, well, everybody has the same question, but there's no answer for this, evidently. At least that's what I find with the GPS. They're like, oh, I forgot to bring it outside. Well, I didn't forget to bring mine outside. It just, it could pick up many satellites. It just doesn't seem to lock. Even though it says that the DBM, can be minus 167. And if I put uCenter to software and I connect up the GPS here, I can see many satellites from inside. So it's interesting to see, is this something, it almost seems like there's something wrong in the Pixhawk and being able to, its ability to either communicate or sense. Yeah, so you have to really research, your power requirements, so you get the right size battery, not too big, not too small. You have enough thrust for your payload. The total cost, you'll want to make sure you don't go over budget. Get a good idea in the beginning as to, how much it's going to cost you. So how are we doing on time? So that's pretty much it. If anyone has questions. So that was, it's an interesting, I think, just from do it yourself, you're going to learn a lot. So it's kind of like school and doing a lab. Although you're doing all the research, you're not getting fed anything pretty much. So you do learn a lot. And the good thing is to write down, or I do a lot of cut and paste into some Word docs so that I'm able to remember links and what problems I had, make little notes so I can go back and replicate it. But yeah, so if you can find something that you want to make, like the drone, and you can find someone who's actually done it and has it pretty well documented, then that's great. And that's sort of what I'm pushing for to put on my website is, all the links and instructions, although there was pretty good instructions for the drone up to the stage of just building it, but then after that it's hard to get information, so I wanted to kind of go on from there and add information.
Starting a project, like when you start a project, like how do you decide what hardware you're going to use? Like said your Raspberry Pi couldn't handle the computation and you decided to go for a Intel NUC. So how do you decide when you start?
Right, so if you know what the sensors are up front that you want to use, it's a good thing to kind of Google and see if there's been people have issues, if you can find anything on YouTube about it. It's good to get some sort of feedback researching that at first, because if it's saying, oh, I have a problem with this, oh, that's a real issue, because the Raspberry Pi 4 is still pretty new, which there are a lot of issues because of that. You have to really, if you really want to make sure things go pretty smoothly, you should do a lot of research ahead. Just, it's kind of like a system design. You got to figure out, well, what sort of operating, you could say, oh, well, I want a Linux. It's like you could start with something at least that descriptive, and then figure out what version might work or not work. I found that there was issues with the ARM processor of the Raspberry Pi with the newer versions of Ubuntu. They're better on the AMD 64, but I've got them to work. So yeah, I have 20.04 working on the Raspberry Pi. But yeah, you definitely have to do research.
I have one more question from chat section. So how do you start a project? Like what do you think before starting a project? It's applications or just for the fun of it?
Right. Well, that's a good question. That's a really good question. I think about the application. What do I want to do? Like the DARPA sub-T challenge. I already had read through the requirements of what they were looking for and what it takes for it to pass. So that's a much more complicated system. But like when I was doing my Rapbot, that just kind of grew. So I didn't know at first. All I had experience with was like the Arduino, and I knew that I was able to do an IMU from the past. So sometimes it grows, so you have to kind of change things out. But the more you know up front, the better planning you can do. And so that's kind of a systems engineering thing you'll find in any place you go to work. You're going to have to kind of plan out the system as best as you can. You're going to keep coming back to it and changing it as you run into issues, or maybe want to add something, or this sensor's not good enough, you find out, and you want to go with something else. And then it can get tricky unless you have a lot of money and you just, keep buying new processors and parts or things. But yeah. So yeah, that'd be my answer.
Is there anyone else who has a question to ask Dr. Zeno?
So go out there and make things. It's a great way to learn. The only thing is that, it can be very expensive, of course, but I always I kind of research, okay, well, this platform is less expensive than, say, that platform. You might get a drone base platform that's like super huge, and it's like $1,000, or I found the one on here that was like $200, $300. So yeah. Got to shop around.
Okay, so I think we have questions left. So yeah, it has been a pleasure like to have with you also. So like the talk about like building your own robots from scratch and going around discovering stuff and finding new applications about. Yeah, so it has been a great session for us. For as a token of appreciation, we have a little something for you.
Oh, thank you.
Surya, please allow me to share the screen.
I have.
Okay, let me share screen. Oh, okay.
So yeah, that's
Oh, wow.
digital
That's
art.
good.
Yeah, thank you, sir. We'll mail this to you by.
Oh, wow.
Hello.
Thank you. Someone did a great job. I actually look pretty good there. Love it.
Sir, I have a question.
Sure.
Sir, I want to know how you are getting idea about the altitude and the rotation of the drone as you are not using any sensor, I guess.
How am I getting it now? The
rotation and the tilts at that altitude.
LD2?
So are you talking about the drone?
Yes.
Yeah, I'm sorry, I don't.
Sir, I want to ask that how you are getting the idea about at which height the drone is and the rotation and tilts.
Oh, okay.
Yes, sir.
Oh, yeah. So when I initially got the drone, it was very low to the ground. And so I was like, this thing wouldn't even sit in the grass. The blades would start chopping up the grass. So I actually did a search on Google, and I found that there was, I can purchase plastic legs that weren't, I don't know, it was like $10 or $15 or something like that. I think I got it on eBay actually. So that was very helpful. And that lifted it up very nicely. I've also, you can see it. So I've also raised up the GPS to see if that take the rotors off. So you're not, I've had this thing just dart off on me a couple times and crash into walls and my hand and my leg, and it's very painful. But yeah, so this had a nice, what they call a racing sled. And yeah, so it's able to fly pretty well. It has, so you have like a shock absorber here so that the flight control unit isn't bouncing around too much. And also that's where I have the Raspberry Pi on top of that also. And then I put a roll cage I decided, I don't know, you have to kind of use your mechanical abilities. Sometimes you might see something and think, oh, that's a good idea, I should do that. Or you might think about, oh, well, I should probably, this thing has flown upside down a couple times and landed upside down, so maybe I should, put a cage on it or something. So it actually would be nice to put rotor guards on this thing too, but I have to work the GPS problem first, or get the camera working, the visual IO working. Yep.
I guess that answers Aman's question. So yeah, Dr.
Yes, sir. Thank you, sir.
You're welcome.
Yeah, so Dr. Zeno, I guess we have no more questions. It has been really great, our pleasure, and for the inquisitive talk. We're really thankful to you.
No, I thank you guys. You did a great job. Sorry I was a bit late. You know, converting the time was a little difficult. Shouldn't have been, but it was. It's that half-hour thing. It's like not perfectly 10 hours. It's like, you know, but anyway. All right. Well, I appreciate it. It's been great. And hopefully somebody's learned something from me. And you can always email me at ZenoRobotics.com or ZenoRobotics@gmail.com. And if you have any questions.
Thanks, sir.
All right. Well, thank you. Have a
Bye,
good
sir.
rest of your day. Bye.